is the problem number 67. Find common elements in matrix rows. I have made this problem already and I can say that it's very interesting. There are many ways to work with this. And in this case it took me quite a while, but yeah. Um, I will show my approach. So the statement says, given a matrix, find all the elements that exist in every row. So for example, if we have this matrix A, then the answer will be 2 and 5. Why? Because 2 is present on every row and 5 is also present on every row. So yeah, those two numbers are the answer and are shown like a vector. Elements should be returned sort ascending. So yeah, from the smaller value to the bigger value. No, there is no guarantee that there are any such elements. If there are none, the routine should return the empty set. Also, the matrix might contain any names, repeats, or very large or very small elements. So let's see. As I already said, there are many ways to make this work. Um, so the code that I chose to do, or the way that I found how this could be done, is like copy the first row of the matrix and make this like a vector. So for example, B, oh, that's too big, something like B could be the next vector. And yeah, we don't need other elements of the matrix like 9 or any other number that could appear, because since 9 is not on the first row, it cannot be part of the vector that is going to be our answer. Only could be 1, 2, 3, and 5 in this case. We are going to check that 1 is present on every row. If that's not the case, then I'm going to erase 1 from the vector. Then check for 2 if it's present on every row, and if that's the case, it stays. And then 3 is if it's present on every row, good. If not, it's erased. And then for 5, if it's present on every row, then it is present. Other way to show it is like check the same way, but also create another matrix, like for example y, and then the answer like 2 and 5 are gonna be part of this new matrix. So in this case it's gonna be 2 and 5 because those are the answers after checking on the original matrix what they are asking us. And this will be our answer. Okay, so let's do it. Let's make it in code. Okay, so now I'm gonna show the code that I work with. In this case, I'm gonna also help myself with the code on MATLAB and also another script where you can show how it's going to work. So yeah, we start easy. Like I put this statement of if in the case that x is an empty vector. This could happen, and actually I made this because there was a test where this needed to be done. So on the case that x is an empty vector, we just say that the answer is also an empty vector, and that's our first case. On the case that the matrix has a lot of values and numerical values, then we go to the main algorithm. So we create another matrix that is gonna have like the first row of the matrix, like this. So in this case, I'm showing this as A, and then S is the size of the original matrix. So I can have the number of columns and also the number of rows. And also I am stating that Y, that is our answer, is going to start as an empty vector, and then we're going to fill the elements that are present on all the rows of the original matrix. So we make a triple 4. This is the way I make it. Maybe there are shorter ways to do it, but this is the way that I come with. So I'm making a for from k to 1 to the length of a. So I'm just taking all these cases for 1, 2, 3, and 5, and then I'm gonna check if they are present of all the rows of the matrix. That's why I make a counter, and then I say for y to 2 to the number of rows of the matrix, we make a trigger, and then for j from 1 to the number of columns, we activate the trigger only if there is a supposition that uh, the element is present on all the rows. So if, for example, 1 is checked on any of these rows, it's not gonna be present. It's not gonna be present. So in that case, trigger stays as 0, and trigger is not gonna be exactly the number of rows. Okay, so yeah, I can stay like 1, 2, 2 times, plus this one is 3 times, so it's gonna be 3 out of 5. But then, since it's not gonna be 5 or 5, it's not gonna be part of the final matrix. This only happens if it's present on all the rows. So yeah, if counter is 5, the number of rows that the matrix has, then that element is gonna be part of the final answer. We make it like this: y is gonna be y plus that element. So if we check for 2, then we see that it's present of all the rows, so the counter is 5, and yeah, since 5 is equal to 5, the counter is equal to the number of rows present, uh, it's gonna be part of the vector that is the answer. That also will happen with 5, and not for 3, because 3 is only present on 3 of the 5 rows. So that's how I make it. This is the way the algorithm works. And finally, I just needed to make something else, which is sorting from smaller numbers to bigger numbers. So I'm just using sort, and then I make a little algorithm on the case that let me check, let me show. If I don't make this, um, yeah, but let me show the final answer. Yeah, this could happen. And yeah, we have a lot of values with 1, but the answer that they are asking us, let me see. The answer that they are asking us is just to get just one number. If there are repeated values, then you just have to erase the repeated or the same values of the final answer. So I needed to erase all this, and I make it with this algorithm. Uh, I don't know if I have to explain this. It's a bit complicated, and I'm not sure if there is a direct command or a straightforward command to do it. I just wanted to make it traditionally. So I just use a while. I use some uh, elements like trigger 2 and counter 2. And yeah, what I just did was just like get this. Uh-huh. And yeah, on the case that this value is the same, sorry, is the same that the next value, then I erase the first one, and then I repeat it again. If this value is the same that this one, then I erase it. I just erase the first, and I repeat it with while. So yeah, that's why there is a while there. Yeah, and then just to not end on an infinite loop, I just make a counter and say that this counter 2 just has a limit, and the limit is the number of elements that we start. So if we have 10, then we can just do this at most as 9 times. If we don't put this, then we are gonna stay on an infinite loop, I guess. Mm, and yeah, that's it. I think there are better ways to make this part, but this is how I make it. Um, Other examples, just to show, um, yeah, something like this could also happen. Mm, Another answer is this one, that is exactly this. And also, this example was a bit tricky, and as you can see, this also was uh, an answer with repeated values that are 0, and I needed to add like the final part of the algorithm. So I could erase all the zeros, but since 0 and 1 are different, they stay. Let me check. I think, yeah. Yeah, but show the answer, please. Okay, so as you can see, with that part of the algorithm, we get this, and that's the answer that they are asking us to get. Yeah, can work with negative numbers, with RNAs, etc. And this was an interesting code. It took me quite a while because I still not used to this type of problems again. Yeah, that was it. Thank you. Thank you for your attention. And let me let me see if you have any problem. I can try to solve it with code, obviously. And yeah, have a good day.